Hello students, I believe that you have learned many things from the videos that I have uploaded earlier to my channel, and I hope that you haven't forgotten to click on the like and the subscribe button so as to encourage me to create some more videos on other topics as well. Now, today in this video, I'm going to discuss on how to find the n number of terms of an arithmetic progression. Now, to find the sum of the first n number of terms of an arithmetic progression, we have to remember this relation, which if a is the first term, d is the common difference, and n is the number of terms of an AP, then sum of the first n terms, which is also denoted by Sn, is equal to n by 2 into 2a plus n minus 1 into d. Or if L is the last term or the nth term means the last term. So Sn or sum of the first term will be n by 2 into a plus L. Now let us go to some questions. Now here in this question it says find the sum of the AP whose first term is 5, 2, minus 1, minus 4, minus n, and so on till n number of terms. Now here, since your first term A is 5, so we write here 5, and D, as usual, the second term minus the first term, so we have here 2 minus 5 equal to minus 3, and n here, since we have to sum to n terms, so n here is n. Now we have Sn equal to n by 2 into 2a plus n minus 1 into d. Now which is equal to n by 2 into 2. Since your a is 5, we put here 5 plus n minus 1 into d. Since your d is minus 3, so we put here minus 3. So this is equal to n by 2 into, since 2 into 5 is 10, so we write here 10 minus, now we multiply this inside, minus into plus is minus, and 3 into n is 3n, plus, again minus into minus is plus, and 3 into 1 is 3. So it is equal to n by 2 into, now 10 and 3 is 13 minus 3n. So if we sum this AP to n number of terms, we will get n by 2 to 13 minus 3n. Now let us look at this question which says find the sum of the AP minus 1, 1 by 4, 3 by 2, and so on to 81 terms. Now here your first term A is minus 1, your D, the second term minus the first term, that is 1 by 4 minus 1, it is equal to 1 by 4. Minus and minus is plus, so we have here 1, which is equal to, now again here 4 into 1 is 4, plus 1 is 5, so we have here 5 by 4. Now n here, it is equal to 81, since we have to sum to 81 terms, so your n here is 81. Now we have Sn equal to n by 2 into twice a plus n minus 1 into d. Now since n here is 81, so S place of n we put 81, so S81 will be equal to, again n is 81, so we put here 81 by 2 into 2 A. Your A is -1, so we put here -1 plus. Again, your N is 81, so we put here 81 minus 1 into, since your D is 5 by 4, so we put here 5 by 4. So your S81 will be equal to 81 by 2 into, now 2 into -1 is -2 plus, again here 80 minus 1 is 81 minus 1 is 80 into 5 by 4. Now 4 times 20 is 80. So we have here S81 will be 81 by 2 into -2 plus, again 20 into 5 is 100, so we have here 100. Now S81 will be equal to 81 by 2 into -2 plus 100 is 98, and 2 times 49 is 98. So therefore S81 will be equal to 81 into 49, we have 3969. So if you sum these given AP till 81 terms, we will get 3969. Our next question says, how many terms of the sequence -12, -9, -6, -3, and so on must be taken to make the sum 54. So the sum should be 54 here. So here, your A, the first term is -12. Your D, second term minus the first term, that is -9 minus of -12. We'll have your -9, minus and minus is plus 12 equal to, so -9 plus 12 will be equal to 3. Now your Sn here, that means the sum is given to be 54. Now we assume that n be the number of terms. Now Sn will be equal to n by 2 into 2a plus n minus 1 into d. Now your Sn here is given, so in place of Sn we write 54, which is equal to n by 2 into 2. Your a is -12, so we put here -12 plus n minus 1 into d, and your d is 3, so we put here 3. Now we cross multiply this 2 into 54, we get 108, which is equal to, then here n into, now 2 into -12 is -24. Now again here we multiply inside, 3 into n is 3n, and minus 3 into 1 is 3. Now 108 will be equal to n. Now this -24 and -3, we combine together, we get -27 plus 3n. Now 108 will be equal to, multiply this n inside, minus n into -27 is -27n plus, again n into 3n here will be 3n squared. Now we transfer this 108 that side, that is, and write in the standard form, we have 3n squared minus 27, and this transferring to the right hand side, we have -108, and we are left with 0 on the other side. Now these numerals 3, 27, and 108, they have a common factor, which is 3. So we divide throughout by 3, we are left with n squared. That means 3n squared, we divide by 3, 3 and 3 is cancelled. So we're left with n squared minus, now this 27, if we divide it by 3, we have 9. So 9n minus, again this 108, if we divide by 3, we have 36, which is equal to 0. Now this is a quadratic polynomial, so therefore we factorize this, we get n squared minus, now 12 into 3 is 36, whereas -12n plus 3n, we have 9n. That means we are splitting the middle term here. And -36 is equal to 0. Now first term and the second term, n is common, so we take n common, we are left with n minus 12 plus. Again, the third term and the fourth term, 3 is common, so we take out 3, we are left with n minus 12, which is equal to 0. Again, n minus 12 is common. So n minus 12, we take common, we are left with n plus 3, which is equal to 0. So from here, n minus 12 is equal to 0, we have n equal to 12. Again, from here, n plus 3 equal to 0. So we have here n equal to minus 3. Now, we know that n is a counting number. N is the number of terms. So therefore, n cannot be a negative integer as it is a counting number. So therefore, we will take n equal to 12 only by neglecting n equal to minus 3. So therefore, the required number of terms will be equal to 12. Again, let us look at another question which says, find the sum of the series, which is 72 plus 70 plus 68 plus da 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 and so on, plus together with 40. Now here your first term A is 72, your D is as usual, second term minus the first term, that is 70 minus 72 is minus 2. Again here, your nth term or the last term, that is L, is given to be 40. So we write nth term or L to be 40. Now we know that nth term here, it is equal to 40. Now A plus n minus 1 into D, it is equal to 40. Now again, your A here is 72, so we put here 72 plus n minus 1 into D, in which your D here is minus 2, it is equal to 40. Now 72 minus, again this we multiply inside, minus into plus is minus, 2 into n is minus 2n, plus again minus to minus is plus, 2 into 1 is 2, so we have here plus 2, it is equal to 40. Now this 72 and 2, if we add together, we have 74, minus 2n will be equal to 40. Now minus 2n will be equal to 40. Now this 74, we bring it to the right hand side, we have minus 74. So we have minus 2n will be equal to, now again here 40 minus 74 is minus 34. So and minus and minus on both sides of the equation, they are cancelled. We are left with n equal to 34 divided by 2. Now 2 times 17 is 34. Therefore, our n here is equal to 17. Now, Sn equal to n by 2 plus a plus l. Now we are using this relation because in this question, the nth term or the last term is given to be 40. So, so your S17, or since your n is 17 here, will be equal to 17 by 2 plus, since your A is 72, we put here 72 plus your last term, which is 40. So S17 will be equal to 17 by 2 into 72 plus 40 is 112, and 2 times 56 is 112. So S17 will be 17 into 56, which is 952. So therefore, the required sum is 952. So at the end of the explanation, I want you to open your textbook, exercise 5D, and you'll try these questions which is there in your textbook so that you will enhance your knowledge further. Thank you.